Good afternoon. I welcome you all at this wonderful conference. I am also very excited to be here for the first time. And my name is Dmitry. Today I will talk about security in crypto transactions. But first, let me start by introducing myself briefly. So I've been working in software development industry for over 25 years. And most of my career I've spent in telecom industry, working in such companies like Nortel, Avaya, Ericsson, Netcracker. By the way, two of those companies, Nortel and Avaya, doesn't exist anymore. That's not my fault. In 2019, I created my own startup, Craft Systems, that became a resident of Skolkovo Innovation Center. For the last 3 years, I'm at the position of CTO in the largest European provider of EUR/S stablecoin named Stasis. At Stasis, we have built a crypto platform that provides many services, including CRM, back office, web application, forex exchange, mobile applications, crypto wallets, and made integration with 6 blockchains. In our company, we deal with blockchain transactions every day. And today I will discuss how to make this process safer and why it's important. So blockchain technologies and cryptocurrency application have become a part of our life, just like the internet before. I hope that most of you have already known at least Ethereum or Bitcoin. Now I want to ask you, please raise your hands who doesn't know at all what blockchain is. Nobody. That's great. And also, please raise your hands who has used at least once the crypto wallet. Almost all people. That's fantastic. So currently there are already thousands of crypto applications, and basically those applications are great amount of different platforms or applications that utilize blockchain or cryptocurrencies for certain purposes. For example, some of them help to use cryptocurrencies like cryptocurrency wallets. Others, like centralized exchanges or decentralized exchanges, helps us to buy or exchange crypto assets. Decentralized finance applications allow to get some income in exchange to providing liquidity or loans. And others, like payment processors, help to perform some crypto payments. The cross-chain bridges provide great functionality for moving assets between different blockchains. However, since inception of the first cryptocurrency applications, there have been constant attempts to hack them by attackers. And this hacking is one of the major things that prevents adoption of cryptocurrency. As an example, in 2022, totally $3.8 billion worth of cryptocurrency have been stolen from cryptocurrency applications. The most high-profile hacks occurred with wormhole breach and the well-known Binance exchange. But the absolute record was set by the Ronin network application hack that resulted in theft of $625 million equivalent in cryptocurrency. That's amazing. So why this could happen and how to prevent this, I will discuss further. But first, let us deep a little bit deeper in the technology. So the basic element of blockchains and cryptocurrency applications is crypto wallet. And the crypto wallet is basically what is helping us to store or receive or send funds to someone. Every crypto wallet has a unique address that is alphanumeric identifier and the cryptographic secret or a private key. The private key is required to have access to funds stored in a wallet and also to authorize blockchain transactions. The address and private key are related mathematically through the special process known as a derivation. So when a private key is first generated for the wallet, then the special elliptic curve cryptography function is used to generate a public key from the private key. Then the hash function is applied to the public key to get the 256-bit number. After that, this number is also encoded by some algorithm like base 58. And finally, we get an address. So in that sense, the address is just a representation of a public key without revealing it itself. There are a lot of different classifications of the crypto wallets, but the most important for us is custodial or non-custodial wallets. The main difference between them is in the answer of the question, who has control of the private key? In custodial wallets, the control is on the third-party side. For example, the crypto exchange that provides this address to the user, and the private exchange has full control on it. For non-custodial wallets, the user has full control and ownership of the keys and also responsibility for the safe storing of the private keys. If you lost the private key, that means you lost access to all your money. I can remind you one famous example when in 2013, one British guy, well-known guy, by the way, his name is James Howells in Britain. He has his crypto wallet with 8,000 bitcoins. And the key of this wallet was stored on his computer drive. He just thrown his computer drive on a landfill. And then he realized that he was very upset because the cost of this money now is about $500 million. Since that time, he's desperately trying to get it back, but no luck. So then the next important process is signing blockchain transactions. For that, the crypto private key is very important because it is used in order to prove that the data sent to the blockchain has not been tampered with, and also this data was sent by the person who is actually owning the private key. How is that happens? First, the sender prepares the data, including recipient address, sender address, and amount. Then, again, hash function is applied to produce 256 number. And now the private key is used to prepare a digital signature from this number. And the ECDSL algorithm, standing for elliptic curve digital signature, is applied in order to get this digital signature. Then this digital signature and the data are sent to the blockchain network. Once it's done, everyone can verify the blockchain transaction, even a blockchain node or receiver. For that, the receiver, for example, takes a digital signature from transaction, then applies a public key that is actually derived from the sender address and produces that 256-bit number. Then he can use the data from transaction, apply the hash function, and again he gets this 256 number. In order to validate this transaction, we just need to compare those two numbers. If they are equal, then the transaction is valid. Sounds simple, but it's very effective. So the private key is crucial in security of blockchain transactions because it's a thing that is authorizing the blockchain transaction. So now get to the example how the real issues can happen with custodial wallets. And take an example for the cryptocurrency exchange. The exchanges usually have some number of operational wallets that are controlled by the software. That means that transactions are performed by the software services. But in order to do that, those services need access to the private key. So that means it should be accessible inside your infrastructure. And then actually opens the security hole. The matter is that those operational wallets can accumulate a big amount of money and liquidity, literally millions. But if someone, for example, a hacker, gets access inside the infrastructure and takes this private key, he can easily generate a transaction and drain the operational wallet completely. The same applies to the user hot wallets that are also usually controlled by the software platforms. So that's a big problem. And what can we do with that? Basically, the security problems are divided into three big parts. First one is how to securely store the private keys. The solution for that problem is usually provided by means of different software or hardware methods to store private information. We can discuss that later. And next 2 points are also important: how to access the private keys and how to execute actually the crypto transaction safely. The answer on those questions lies in the software architecture and special algorithms that is used for specific services that are involved in execution of transactions. And we can consider it later as well. So let's consider possible options for organizing the secure storage of private keys. One option is using hardware security models. This is actually specifically designed physical devices, hardware devices, that are used for secure management of key and perform some cryptographic operations. For us, it's very important of some of the features. For example, the highest cryptographic security that is provided by hardware-based cryptography. And also, they provide special mechanisms for protection of inside threats from the personal and malicious actions. And they also provide some crypto operations. They can encode, decode, they can generate the keys, they can provide digital signature. That's all great. However, they also have some disadvantages that are critical for us. First of all, they can be very expensive to purchase and maintain. They can be very complex in installation and integration and require high expertise. Also, using that, you are imposing a dependency on hardware vendor, and also they have a limited case size. So because of that, we did not choose that option. Another, again, hardware option is using software guard extensions, SGX. And SGX is an Intel technology that provides a special set of security-related instructions for Intel processors. And SGX basically allows to create protected region in the memory that is called in Intel technology EPC, that stands for enclave page cache. Enclave means protected. Again, this is cool technology that provides a safe and secure execution environment that absolutely isolate your data and code from the rest of the system, even from the hypervisor. So you can safely execute your part of crypto transactions, for example, there. That's all good. However, again, for us, it doesn't cover all our use cases. First of all, we can have complex scenarios for signing transactions, but SGX provides only limited EPC size. So for us, it will be a limitation. Also, this technology is hard to use in a cloud environment, for example. And again, that imposes dependency on a hardware vendor. So that's not a good option for us as well. Now, there are also a number of software solutions which are secret management systems. And those systems basically provide such features as centralized storage for storing the private information and encryption of this storage. And also they have sophisticated role-based access control, lock and audits, safe backups, etc., etc. So that's all good. The most famous and known systems are provided by the Amazon, the Microsoft, And also there is an open source system HashiCorp Vault. So among all these systems, the third one is the most attractive because it's an open source. So let's take a more deep look at this. By the way, I want to ask you, who is using in your organizations the HashiCorp Vault? Oh, so many people. So you must know about it a lot. I will not be long describing its benefits. So I just say that for us, the key advantage is an open source. You can use this open source version on-premise, in cloud, in hybrid setups, and manage it completely. Also, it has a wide amount of authorization methods that is useful for integration with your systems. And it's a large ecosystem, and it's in active development. It's constantly providing updates of the software. So that's a great option. So that's why we used this Vault open source version as a basis for our solution. Now, just a couple of words about Vault integration. You maybe know some of that. I just remind. So before you can use Vault, you need to set up a storage, and Vault has a big list of possible options for that. The typical option is using a disk or console, and there is also option for using external storages, which is also very flexible. And when the Vault starts, it begins with a sealed stage. What does it mean? It will not go further until you provide an unsealed key. The unsealed key is a token that is generated during the installation and setup. And that is usually divided into parts, the unsealed tokens. And in order to unseal, you need to provide some parts of it, for example, 3 or 5. That very similar to multi-signature in a crypto industry. And that is very secure, because even if someone stole your data, he cannot start the Vault server without providing an unsealed key and get access to the storage. And access can be in 3 forms: using the web UI, using the CLI, or having an API for the applications. For each of these storage, you need to have an access key. And for application access, this access key is usually temporary. For CLI is also, because the IT staff usually doesn't have access, direct access to the storage. They are usually provided with a temporary token just to maintain, to do some maintenance work, configuration work, etc. Okay, now we get to the most interesting part. I guess I will show you how we implement our secure transaction architecture. Here you can see that we have HashiCorp Vault server and the encrypted storage, also with the sign-in application inside the isolated enclave. The enclave means a dedicated machine or server which is hardened, where the special measures are taken in order to protect it as maximum as possible. And the sign-in application is our service that is communicating with the HashiCorp Vault in terms of getting or putting the security keys into this storage. And no application outside can access the security storage. It can only communicate with the sign-in application. As you can see here, the end client communicates with our web application. Then on backend, our web API communicates with the crypto payment service that is actually doing transactions. And it in turn interacts with sign-in applications in order to get signature for the transactions to actually run them. That provides the maximum security possible for our architecture. So let's go deeper a little bit for the services. The crypto payment service, its main purpose is to make transactions. It serves for basically 2 use cases. First, we receive funds from the client, and then we send funds to the client. For the crypto deposits, we have a number of listener processes that are connected to the crypto node, and we are monitoring constantly the incoming transactions coming to the blockchain. When we see some transaction with the recipient address that matches one of the address of the wallet registered in our platform, then it takes this transaction, decodes it through the Explorer service, and put it in a database. Then the crypto payment takes some further actions to finalize the processing, like moving these funds from one wallet to another, making some notifications, etc. And the crypto payment is providing the high throughput for the operation and supports 6 blockchains. It takes REST API for basic methods like to provide the wallet address and just to send transaction. That's it. The sign-in application is a core part of our architecture, and its main purpose to isolate the private storage of the security keys from the applications that are making transactions. And it communicates, only this service communicates with the vault storage for 2 purposes: either get a secret or create a secret in a storage. That's it. Outside, it provides the API for creating wallets or get wallet address. Another part of the service is actually transaction service that provides signing of blockchain operations. The requester outside, in our case, it's a crypto payment service, makes a request to sign a transaction, sending a pre-prepared transaction. The transaction service asks wallet service. It in turn accesses the crypto storage and gets the private key. Then the digital signature is generated, attended to the crypto transaction, and the ready transaction is sent back to the crypto payment service. And then it can be sent to the blockchain. So let's consider the scenario of receiving deposit, a crypto deposit from the client, and from the security perspective, how it's actually executed. So first, in order to let our user to send the crypto funds to us, we need to provide him an address of his hot wallet. The crypto payment goes to the sign-in application and asks for this user if there is an address. If there is, then we just provide this address. If not, we create it and then also provide an address. After that, the user sends us crypto funds. And once we notice the transaction is coming to the hot wallet, the next step for the crypto payment is to move these funds from the hot wallet to the operational wallet. And that's important part because here we need to have a private key of this hot wallet. But the private key is stored in a secure storage, in an enclave. So to do that, crypto payment prepares this transaction, putting all the parameters inside the transactions, the recipient, the sender, the amount, etc., and send this transaction for signing to sign-in application. We have already discussed it. So the sign-in applications signs this transaction and then send it back to the crypto payment. And it, in turn, send it to the blockchain, and the operation happens. Let's imagine what can be done by a malicious person, external or internal, in order to intercept some information or steal money. What type of intrusion can be? Usually it's a social engineering, just to get into the infrastructure. By the way, there is a recent case in last year. It was a CoinSpade company, an application payment processor that had been attacked. And by means of social engineers, attackers intruded inside the infrastructure, and they stolen 37 million dollars in cryptocurrency equivalent. Because the private keys were not secured. That's the main reason. So in our case, the hacker goes inside the infrastructure, and what he can find? Nothing. The private keys are not stored anywhere in database, in configurations of services, on a disk, nowhere. There is no luck for him. Okay, so then what he can do? He can go further and penetrate the protected enclave. First of all, it's much harder task because to do that, he needs SSH keys to get into this protected enclave. But suppose he gets these SSH keys and get inside. Again, what he can do, if he even access the protected storage, all the data in protected storage are encrypted. So without providing an access key, he cannot get the private keys. Also, because this enclave is hardened, he cannot take or intercept any data inside between the processes communicating to each other. Even if he gets the signed transaction, for example, he can get nothing because in the signed transaction there is no private key. So again, he cannot use it. So we can see that this architecture provides a certain level of barriers on the way of the hacker that prevents him to do his work. The same actually can be explained here for executing transfers, where we need just to send transaction from operational wallet to the external wallet of the client. And again, this crypto payment access the signing application in order to get the transaction signed. I specifically note again that crypto payment service here does not access the private keys directly. It just provides the prepared transaction and asks for signing it. And actual signing is done inside the enclave, the protected contour. So that means the private keys never leave the protected contour. That's the main rule. Finally, some words about security. Security professionals know that providing security is a never-ending story. Even if you think that you secured everything in your infrastructure, you may be wrong. There is always a possibility for security hole. So for us, the main important thing is to protect the enclave. And even if the SSH keys are compromised, to make the life of the hacker as much hard as possible. To do that, first you need to do some operation system hardening. I already mentioned it. For example, restrict core dumps, memory dumps, to install all latest security patches, to revoke grants from the folder where the security storage is actually exists, etc. And other measures as listed here. Additionally, you can go further and implement, for example, CLinux or AppArmor policies, which is a very powerful instrument for the Linux on a kernel level. And if you do that, you can protect it very much. So basically, that's all from my side. Thank you very much for your attention, and I'm ready to answer your questions.
Please point your phones on this QR code. If the QR code displays just the talk page, please log in so you can actually vote. And now we can start with, by my opinion, the most interesting part of any technology conference is this discussion thing. So, how long your system is in production?
The latest version actually in production for 6 months. And so far, there were no incidents. But I must say that we didn't have incident. This is commercial information. I cannot reveal it. There was only attempt for incident before, much before that. And because we noticed that, we started this endeavor to create a new architecture.
Please raise your hands if you have questions. Otherwise, I will ask them. Please.
Thank you, Dmitry, for your speech. The first question is just about the architecture. So, for HSM, for example, you said that there is a con that there is a limited key size over there. Do you use any key derivation algorithms to optimize key space and proceed with the virtual keys instead of, creating key for each client or for each, let's call it, company wallet, or not, and why?
Of course, thanks to HashiCorp Vault, it's very flexible in terms of secure storage, and it can help us organizing the very deep structures and the trees of data. And for that, we use a separation of data between legal entities, and also for each client, of course, we create a dedicated address and a private key.
Okay, I see. Thank you. The next question, two questions will be regarding the architecture and security. So you said that to start Vault, you need to unseal it to use it. But as soon as you unseal it, it stays in a sealed state. So otherwise, it will require for administrators each time to input, for example, 3 or 5 keys. So it means that keys inside the Vault are unencrypted in real time. So it means that if someone gets an access to the Vault API, for example, he can proceed with the calls to sign the data and get the proper signature. So how you protect against attacks such like this one?
Well, if I understood correctly your question, you think that if we unseal the storage, unseal the Vault, all the data are just plain and unsecure. That's not true, because all the data is encrypted inside the storage. Even if you get access to it, you cannot get data.
It's encrypted in memory.
It's encrypted in a storage. On disk or external storage, all data is encrypted by the master key, which in turn is encrypted by the root key. So it's like a hierarchy.
Yeah, but in memory, I mean the RAM, it will be unencrypted.
I think Vault does not store anything in memory. That's inside the architecture of Vault. I cannot be...
Let me rephrase the question. If some person has a root access to this Vault machine, can execute some code as root, can read and write memory, will they be able to intercept requests, Vault API, and get private key from memory?
Okay, I got your question. So I think I already explained this, saying that inside the isolated enclave, you must provide a set of measures to prevent things like that. So you need to restrict taking a memory dump, core dump, or something like that in order to prevent accessing to the memory.
Okay, and the last one. So can you please open the scheme where you have a crypto payment I think that's enough. So you said that you are protecting the enclave, but how you proceed with the protection of the services before the enclave? For example, on your schema, it's the crypto payment service. So it means that if someone gets an access, for example, insider gets an access to the crypto payment service, it has all the keys to proceed with the enclave's service, and he will be able to proceed with the transaction signing. So how do you protect against this?
Okay, thank you for this question. That's not actually true, because all our services inside our infrastructure are also using authorization in their calls for API, and we actually use for that purpose key clock. Key clock is an enterprise-grade system that is widely used in many organizations, including NASA, CERN, and some others. So the key clock is everywhere. It's protecting all our services.
Thank you for the answers. So I have a couple of more questions related to the pros and cons of different approaches. So you mentioned HSM, you mentioned kind of secret management platforms, among them HashiCorp Vault, and also you mentioned Intel SGX. So for me, it sounds like these are 3 absolutely different things sitting on different layers. So then we are talking about Intel SGX. That's about protecting the computing environment. So how the information is processed by the CPU. Then we are talking about HSM. That's about protection of the crypto operations. like you don't only store the key inside HSM module, but you execute basic encryption, decryption, signing operations inside HSM. And then we are talking about secret management platforms. That's about storage of secrets. So finally, you get a private key from HashiCorp Vault, deliver it to signer, and signer does without Intel SGX, without use of HSM or something, just does crypto operations inside of it. So sounds like the combination of three will be a good approach. But you are comparing three different things and choosing one of them.
Okay, let me try to answer. You're probably right that those three methods of storing private information are a little bit different, and they have different niche of implementation. And for example, HSM are widely used for providing, for storing data, like for card providers, for example, in banking sector, very widely. And anyway, their functionality is intersecting in a sense that all of them provide the method for storing sensitive information. For us, the most important part was exactly storing the sensitive information. And I was comparing all of them in terms of this. Of course, not taking into account factors that are not important for us. I mentioned this. So that's why we have chosen the software solution, because it's perfectly solving our problem at that with no cost.
Okay, and the second thing, just to mention, you said that there are no cloud implementations of Intel SGX. I know at least two. One of them is SGX virtual machines in Asia, and the second is AWS Nitro that use similar technology like Intel SGX. Have you tried them? Because there was among pros and cons of SGX approach, there was mentioned that there is no cloud support of such an approach.
I know that there are other options. I know that AMD, for example, also providing this similar technology, but not sure if I understood fully your question. So what?
Yeah, one of the cons of SGX was like there is no cloud support.
One of the cons was
maybe it was just mentioned.
Cloud in cloud environments.
Yeah. So at least Asia and AWS, they support this.
Okay, but it's not only cons that we considered. There are others, like limited EPC size. But it's a good point from you, of course. But first of all, we don't want to be dependent on hardware. That was the main driver, I think, of our decision. That's why.
By the way, during your talk, you mentioned this Intel enclave technology. Am I correct that HashiCorp Vault, it handles all the hardware interactions with the Intel CPU to actually use this enclave technology?
No, I don't think so. I know that HashiCorp Vault provides a cluster functionality that you can set up it in a cluster like master-slave with several nodes. That provides sustainability. If some of the nodes becomes unavailable, it's still running, you don't lose your data, etc. But it doesn't directly manage the hardware.
Got it. Also, this security scheme that you explained, for me, it resembles what services like LastPass do. They basically use user credentials like password, for example, in order to encrypt and decrypt some secure storage in real time. And without the access to actual computer memory, it's not possible to get some sensitive information like private key without knowing this person password or authorization. Does this scheme with isolated volume enclave resembles what LastPass does? So does this scheme uses some information about the user, some authentication information to encrypt and decrypt data? Or does this work the other way around?
Actually, the secure storage don't know anything about the end users, and the authorization is done in a different way. For the end users and business users, as I already answered, we have the key lock system as an identity manager, and that is also used for identifying and authorizing all API calls inside all the solution between the services. But to access the vault, you need to be compliant with its rules, its authorization method.
Any other questions? Or I will continue to ask him tricky questions. So please help the speaker ask questions yourself.
Thank you for the report. Tell me, please, do you use some strategies with multi-signature in signature transactions?
That's a very good question. Thank you. That's a different story a little bit because as a cryptocurrency vendor and issuer of stablecoin, first of all, we need to mint it to create tokens, right? And this process is very crucial because if someone gets access to that part, he can mint billions of tokens and the price will go just to the zero. So you need to control that absolutely reliably. And we have a separate system for that. It's called token management system. And on every blockchain where we support our token, we have the multi-signature implemented. And we support the hardware wallets for that, Ledger, actually. There are two major, Ledger and Trezor. We support Ledger, so all the owners of the treasury wallet where the actually token is minted, created, is controlled by a list of owners. And to create it, you need to provide some part of the keys. For example, 3 of 7, or 3 of 5, or 4 of 7, as you wish. Yes, of course, we do that.
By the way, you have mentioned about client authorization and authentication. What kind of authentication ways do you support? Like, can user log in with Facebook?
Yes, we can do that. Not right now. We currently support the just basic authorization login password and two-step authentication, of course, by email, by SMS, etc. But it's all on the KeyCloak side, actually. The KeyCloak is a great solution that out of the box provides mostly all the possible ways of authentication, including OAuth 2, LDAP, almost everything. So we just did not have time to use all types of authentication, but potentially, yes, we can do that.
Thank you.